Well, welcome to week 3. We're zooming right through this semester. First thing I want to talk about right now is there's actually already been a couple of questions for section 1.2. Section 1.2 is not due until later this week, I think Thursday. But there are a couple of people who were struggling a little bit with it. Let me just go ahead and pull up an example here. Let's see if I can actually do the correct screen this time, unlike last time. Is it that one? Hey, I think that's right. Okay, so this is question 11 of section 1.2. It's the last question of 1.2. And so you'll notice this is it's a piecewise defined function, which is a little bit tricky to think about at first. But really what it's doing is it's acting as 3 separate functions. So first off, it acts as f of x is equal to -1. So it only acts as f of x equals -1 when x is in this range though. So when x is less than -2. So f of x equals -1, that sounds like that's it's a horizontal line. It has a slope of 0 if you want to think of it that way. So what you would need to do is you need to say, okay, well, when x is less than -2, that means we're over here somewhere. Let me just get rid of that. All right, so if you're over there, there's a couple of things that people are having issues with on this problem. First off is the first thing I want to point out is that there are 2 different types of ways to write lines here. This one right here is a line segment that only goes between the 2 points that you draw. Again, if you want to get rid of something from drawing it, just drag it off the screen. But what you can do is with that one, that's just between the 2 points. But with this one, this is more of a ray. You stay where it's going to start from and then where it's going to go to. And it keeps going beyond that. So if you want something that continues off the screen, you'll want to use the ray here. So let's drag that off the screen to get rid of it. So if I want to say x is equal to -1, well, that's going to look something like this. If f of x equals -1, that is. But this is I only want that to be the case when x is less than or equal to -2. So this one I can just drag over here and do something like that. Okay, so it's a little difficult to notice. Let me just put the 2 of these side by side. It's a little hard to notice the difference here, but you can, especially if I'm not selecting either of them. You can actually kind of see the difference. On this side, there's no noticeable difference, but on this one, you can see the ray goes a little bit beyond where I drew it to. So that's kind of how you can tell if you've used the correct one or just remembering which one you've used. The other thing to take note of here is using these, you need to either say if it's going to be a closed circle or an open circle. And that's going to say if it goes up to but not including the endpoint, it'll be an open circle. Up to and including the endpoint, it'll be a closed circle. So in this instance, we have, you can see it goes x is less than or equal to -2. So it'll go all the way up to and including when x is equal to -2. So we want to use a closed circle there. All right, so keeping in mind that we need to use rays here, you need to define what your endpoints are. And then the other thing that a few people had issues with is this middle section here. So this is just one portion of this piecewise defined function. This portion in the middle where we have f of x equals x, if you think about what that line looks like, if it wasn't limited, it would look something like this. Remember, this is a slope of 1, y-intercept of 0. So we would just need to restrict it to the proper area, restrict it to wherever we end up being here and the other side. Of course, I did a ray here, so that's wrong. But so yeah, just a couple of things to take into account when you're doing this. Don't just copy what you see on another one. Actually think through what each of these parts are saying, because a few people, like I said, are having issues with that. All right, the next part, the next thing I want to talk about is we're finishing up not just, we'll do all of section 1.2. But then we'll also get into section 1.3. So I wanted to give you a little bit of a heads up on section 1.3. You can see the title of that section is Rates of Change and Behavior of Graphs. The average rate of change We end up using that quite a lot during that section. And I just want to point out this delta y divided by delta x. This is exactly our slope formula. It's our rise over run. Your delta y is the change in your y coordinates. The delta x is the change in your x coordinates. So that's that's your traditional slope, your rise divided by your run. Now, when we're doing a lot of these, we do the y2 and the y1, the x2, the x1. Don't let that really confuse you too much. Just remember that we're doing the difference in the y coordinates up here, doing the difference in the x coordinates down here. Since it is a difference and we're in math, we do have to pay attention to the order. So you want to keep it consistent. So we typically do your final position minus your initial position, and that'll give you the difference in your position. So in any case, that's your average rate of change. That's how you compute it. You'll end up using that on quite a few of the questions in the assignment. Then the other thing I wanted to talk about that I'm not sure is gone through in enough. I have the page number here. It's page 43. Not sure it's done in quite enough detail here, but I'm not sure if it's difficult or not. This idea of concavity, something being concave up versus concave down, and the idea of an inflection point. So looking at these graphs right here, this one right here is considered concave up. A way to tell that, so a cave is, if you have your mountain and you have a cave going into the mountain, when you talk about something being concave, or the side of concavity, is if I was to draw a line along here, you can see I end up above the line. If I was to go from the graph to the graph, I end up going strictly above the line, no matter where I am here. That's one way to tell that you're concave up. If you draw a line between 2 points and you stay strictly above them, then that's concave up. Similarly, this one right here, if I was to go draw a line from this point up to here, I would have to be strictly below this graph. So that tells me that this graph is concave down. The idea of inflection points, so they have a couple of examples here: concave down, concave down, concave up, concave up. You can be either increasing or decreasing when you're concave down. And I think that might be one thing that gets confusing for some people, but the concavity really has to do with which way it's curving, not if it's currently going up or going down. That's kind of irrelevant. It's which way is it curving. So an inflection point, this is a good example, a graph that has a couple of inflection points. So from this portion to about here, I'd say, this graph is concave up, because if I was to draw lines anywhere between 2 points on this graph, I would be strictly above the line. But right at the inflection point, if I was to draw a line going from one point on the graph to another point on the graph, you can see I'm pretty much on the graph. But then if I go beyond that, say from here over to here, I'm starting to go below the graph. So it switches from concave up to concave down. And that tells us there's an inflection point right here. Similarly, we have concave down over here and concave up over here, which says that there needs to be an inflection point somewhere between them. So looks like it's right about where my cursor is here. Looks like another inflection point. Actually, it's probably more like here. It's kind of hard to tell, but in any case, those are the ideas of concavity, inflection points. We'll definitely be using that a little bit more, especially you'll notice when you're concave up, your values are wanting to go more up. This is getting a little bit beyond where we probably need to be right now, but your values are definitely decreasing quickly. But because this is concave up, the rate at which they're going down is slowing. And it slows so much that, right here, our values cease to go down and they start to go back up. And that has to do with it being concave up. From here, when we switch to concave down, we were going up, but since it's concave down, the rate at which we're going up is slowing to a point where eventually we stop going up and we start going down again. And then we talk about concave up again. It starts to go down fairly quickly. And then as it's concave up again here, which means that it's going to be the rate at which it's going down is slowing, and it ceases to go down here and it goes back up. So in any case, those sorts of that sort of analysis is eventually where you're going to want to actually we're starting in on that. So in any case, I'm going to stop babbling. I'm trying to make these videos enough so you can hopefully get some information out of them, but without being too incredibly long. I know there's a lot of videos for you to watch already. But hopefully that clears up any other potential questions for question 11. I'm getting quite a few people who are actually asking questions through messages, which is great. Keep that up. If you're struggling on any of these, I'm here to help. That's the whole reason I'm here. And if I end up seeing a lot of people having the same question again, I'll actually talk about it on one of these videos. Who knows if people are still having issues with it, I might pull out a piece of paper and pencil and actually try to clear it up a little bit more. But it's great feedback for me when you guys are, so I can know what questions you have. All right, so in any case, that's the material for week 3. Hopefully you're able to get through that in a reasonable amount of time. I imagine, hopefully the amount of time you're spending on this has gone down somewhat from the initial lesson 0 stuff. I know those were long, I apologize. But this is new material now. So yeah, have a great week and I'll talk to you soon.